On this question, we're given the piecewise defined function f of x equals 5x minus 1 if negative 5 is less than or equal to x is less than or equal to 5, and x cubed minus 5 if 5 is less than x is less than or equal to 6. And what we want to do with this piecewise defined function is find f of 0, f of 1, f of 5, and f of 6. So let's start with f of 0. If we want to find f of 0, this notation indicates that x is equal to 0. And with a piecewise defined function, we're given these conditions on which to use the specific equation. So since x is 0, and 0 is in between negative 5 and positive 5, we're going to use that first equation to evaluate the function. So f of 0 is 5 times 0 minus 1 equals 0 minus 1, which is negative 1. So f of 0 equals negative 1. Then we'll find f of 1. 1 is the value of x, and just like before, 1 does lie in between negative 5 and 5. So we'll use that first equation in order to find f of 1. f of 1 is 5 times 1 minus 1, that's 5 minus 1, which is 4. So then we want to find f of 5. So x is equal to 5, and with our inequality, we have negative 5 is less than or equal to, and less than or equal to 5. So since we are equal 5, and this inequality has equal 5, positive 5 does lie within that interval, and we'll use once again that first equation. So f of 5 will equal 5 times 5 minus 1, that's 25 minus 1, which is 24. Finally, we want to find f of 6. This indicates that x equals 6, and we'll use the second inequality this time. 5 is less than 6 is less than or equal to 6. So x is equal to 6, and this inequality equals 6. So this time we'll use the second equation, x cubed minus 5. So f of 6 is 6 cubed minus 5. 6 cubed is 216, and 216 minus 5 is 211. So f of 6 is 211. In this example, we're given this graph, and we want to find the function that matches the transformed graph. So first we need to start with the base function. By analyzing the shape of the graph, we'll know which base function to start with. So I see here a V-shaped graph. It does happen to be upside down. You can definitely notice the sharp turn here that creates that V. And when you have a V-shaped graph, then that indicates that your base equation or your base function is the absolute value function. So the absolute value function does have a V-shaped graph, and that sharp turn occurs at the origin, so at 0, 0. So if you'll notice that our sharp turn does not occur at 0, 0. It does occur on top of the x-axis, but it looks like it's shifted to the left. These tick marks here, based on this being a negative 17, looks like they might be going by 2's or 4's. Let's count it out here. So this might be -2, -4, -6, -10, -12, -14, -16. So that doesn't seem to be quite right. Let's see if we can try that again. Okay, could it be going by ones? If it goes by ones, that would be -1, -2, -3, -4, -5, -6, -7, -8. Nope, that's not right. So this does look like it's a 3 here, so maybe that tick mark is a 2. So let's try that one more time. So this one would be -2, -4, -6, -8, -10, -12, -14, -16. Okay, I think I must have skipped a number the first time I was counting. So based on that, it looks like this sharp turn has moved from 0, 0 to -7, 0. And that indicates that we have a shift. It is a horizontal shift because we're moving left. And that is going to indicate in our equation that we would have y equals absolute value of x plus 7. So by putting plus the shift, plus the amount of the shift inside the absolute value, that's going to shift left the 7 units that we want to go. But that only gets us the graph with a V shape pointing up. So we want to use the second type of transformation called a reflection in order to have a reflected graph, this V shape that's been turned upside down. So the V shape originally starts pointing up like this, and we want to reflect it vertically. And to reflect it vertically, we're going to include a negative multiplied onto our base function. So if we have the equation y equals negative absolute value of x plus 7, that will match the graph that was given to us. In this example, we want to find the function that matches the graph that's given above. So we want to start off by first figuring out the starting function or the base function. So we notice here that in this picture we have these two straight lines that come to a V, come to a point, and that indicates that our equation, our base equation, is y equals absolute value of x. So the graph of that has a V-shaped graph which comes to a point at the origin at 0, 0. So if we notice the starting point of 0, 0 for that point, that V-shaped point, and the new place where that comes to a point, we notice that that is 1, 2, 3, 4, 5 units to the right. So we say that is shifted 5 to the right. So we have a shift that is a horizontal shift, meaning either left or right, and we have one shifted to the right. And so that's going to indicate how we write the equation. So if I want to shift to the right c units, I'm going to put minus c inside of the base function. We want to shift 5 units, so we're going to put minus 5 inside of the base function. So y equals absolute value of x minus 5 will shift the absolute value graph 5 units to the right. And this is the equation that we're going to use to match our graph. Starting with the graph of the basic function, graph the following function using the techniques of shifting, compressing, stretching, and/or reflecting. Find the domain and range of the function. The function we're working with is g of x equals x cubed plus 2. So we have a base function using this right here, this cube, to indicate what our base function is. It's going to be y equals x cubed. And let's take a look at what that base function looks like. I'm going to graph it in black. And with an x value of 0, 0 cubed would be 0, 1 cubed is 1, and 2 cubed is 8. Negative 1 cubed would be negative 1, and negative 2 cubed would be negative 8. So our basic function, or the x cubed graph, has this shape. And that will be the shape of the function that we're trying to graph. We do have a transformation here of a plus 2. And I'm going to look at my chart here and see if I can figure out which one of the shifts I have. Now, I knew that it was a shift because it's a plus 2 and that's adding or subtracting. That plus 2 happens outside of the base function, so I know this is a vertical shift, and we're adding, so I know my shift is going to move up. So I'm adding C, I'm going to shift up C units. So every point that's on this base graph is going to get shifted up 2 units. So I'm going to shift each one up, so this 8 becomes 10, this 1 becomes 3, this negative 1 becomes positive 1, and negative 8 becomes negative 6. So this gives us the transformed graph of x cubed plus 2. On this one, we want to graph the function using the techniques of shifting, compressing, stretching, and/or reflecting. We're going to start with the graph of the basic function shown below. We've got g of x equals 6 square root x. So we don't have the basic function shown, we're going to reproduce it. And our basic function is the square root graph. So we're talking about y equals the square root x. That's our basic function. We can only take the square root of 0 and positive values because the square root of negative numbers will give us imaginary and we won't be able to put them on our graph. So we're going to use, starting with 0, positive numbers only. So we've got 0 and then a positive 1. I'll choose a positive 4, a positive 9, and 16. I've chosen these numbers strategically to be perfect squares so that when we calculate the square root, we get nice ordered pairs to plot on our graph. So this will give the square root of 0, which is 0, the square root of 1, which is 1, the square root of 4 is 2, the square root of 9 is 3, and the square root of 16 is 4. So the ordered pairs that we're going to plot for our basic function are 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. So we'll plot those points. We have 0, 0, 1, 1, 4, 2, 9, 3, and 16 is going to be a little bit of our picture, so that's 13, 14, 15, 16, 16, 4 would be about there. So this is the graph of y equals square root x. But we want to graph the transformed function g of x equals 6 times the square root of x. So we've already determined that our base function is y equals the square root of x, and we're trying to graph g of x equals 6 square root x. So we have one transformation, and that one transformation is the multiplication by 6. When we have a multiplication by 6, that's an indication of either a stretch or a compression. So the way we determine which one it is, and there's a vertical stretch, a vertical compression or a horizontal stretch or horizontal compression. So what we notice is that the 6 is multiplied onto the square root function, and that is outside of the square root function. So we know that this is either going to be a vertical stretch or a vertical compression. And the way that you tell the difference between a stretch or a compression here is the value of the number. This number of 6, let's call it C, is greater than 1. So because that 6 is greater than 1, that makes this a stretch. If the number was in between 0 and 1, like a half, it would be a compression. So we're going to take this starting graph right here, y equals square root of x, and we're going to stretch it vertically. And what that means literally is that every y value will get multiplied by 6. So we have this ordered pair at 0, 0 has a y value of 0, and it will still be 0. 0 times 6 is 0. Then this point has a y value of 1, and that will become 6. 6 times 1 is 6. So it becomes 1, 6. And this next point here has a y value of 2, and 2 times 6 is 12. So that point becomes 2, 12. And so you can kind of see that our graph is getting really stretched out. It's almost hard to notice that it's going to be curved. So it's stretching out like this and will become the same shape but stretched out vertically. So I noticed that I made a small mistake with where I placed my points, at least my second point here. So this point that I used is 212 instead of 412. So let me make that correction so that we can see this picture a little bit better. So it should be 1, 6 and 412, and now it looks a little bit more curvy. I didn't do the other values because they're going a little bit too far off my picture. So this is where we see that square root graph going.